Alright, we're going to get into solving systems by graphing, and we're just going to go immediately into a couple of examples that you need to make sure you write down and make note of how to set up and solve each one of these graphing problems.
In this problem, you will graph a system of equations. What is the solution of the system? Use a graph. The first equation in the system is y equals x plus 2. The second equation is y equals 3 times x minus 2. Graph both equations in the same coordinate plane. How does graphing each equation help you find the solution? A line represents the solutions of one linear equation. The intersection point is a solution of both equations. For the first equation, the slope is 1. The y-intercept is 2. For the second equation, the slope is 3. The y-intercept is negative 2. Start at the y-intercept, 2. Then use the slope to find the next point by going up 1 over 1. Then draw a line through the points. Start at the y-intercept, negative 2. Then use the slope to find the next point by going up 3 over 1. Then draw a line through the points. Find the point of intersection. The lines appear to intersect at the point 2, 4. Check to see if the point 2, 4 makes both equations true. Substitute 2, 4 for x, y into the first equation. The point 2, 4 makes the first equation true. Substitute 2, 4 for x, y into the second equation. The point 2, 4 makes the second equation true. The solution of the system is 2, 4. Now it's your turn.
Okay, pause the video and graph this system of equation. Make sure that you extend your lines on out so that you can look for the intersection point if one does in fact exist. And once you've done that, come back to the video and I will show you the answer. Now, these are actually a couple answer choices that you can pick from, and this will also help you to see if you're on the right track with your graphing. And the correct answer for this got it question is A. So if you have any questions about that, be sure when you return to class you ask about this got it question.
In this problem, you will write a system of equations. Scientists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? Alligator 1 initially weighs 4 pounds and grows at a rate of 1 5/10 pounds per month. Alligator 2 initially weighs 6 pounds and grows at a rate of 1 pound per month. Relate the terms to each other in order to build an equation. The weight of an alligator is the initial weight plus the growth rate times the amount of time it has been growing. Now, define your variables. Let W equal the alligator weight. Let T equal the time in months. Now, write the equations. First, write an equation that represents the weight of alligator 1. The alligator weight can be represented as W. Is means equals. The initial weight of alligator 1 is 4 pounds, plus the growth rate of alligator 1 is 1 5/10 pounds per month, times time is represented by T. Now write the equation for the second alligator. The alligator weight can be represented as W. Is means equals. The initial weight of alligator 2 is 6 pounds, plus the growth rate of alligator 2 is 1 pound per month, times time is represented by T. The first alligator's equation is W equals 4 plus 1 5/10 times T. The second alligator's equation is W equals 6 plus T. Graph both equations in the same coordinate plane to see when their weight is the same. For equation 1, the slope is 1 5/10, or 3 divided by 2, and the W-intercept is 4. For equation 2, the slope is 1 and the W-intercept is 6. Start at the W-intercept 4. Then use the slope to find the next point by going up 3 over 2. Then draw a line through the points. Start at the W-intercept 6. Then use the slope to find the next point by going up 1 over 1. Then draw a line through the points. Find the point of intersection. The lines intersect at the point 4, 10. This means that after 4 months, both alligators weighed 10 pounds. Is there another way to solve this problem? Yes, you can make a table. Show the weight of each alligator after 1 month, 2 months, and so on.
An example of a table for the alligators would look something like this, where alligator 1 at 0 months, when the alligator was born, the weight is 4 pounds. And then every month, this alligator is going to grow 1 1/2 pounds. That's the rate of change, or that's the slope. So you're going to go up or increase 1 1/2 pounds every month. And at 4 months, you're at 10 pounds. The same thing goes with alligator 2. This alligator rate of growth is 1, and he starts out at 6. So you increase by 1 every time. And again, at 4 months is 10 pounds. So that's where your two alligators will be the same.
Now it's your turn.
So I want you to try this Got It question. It's based on satellite radio service, and set it up the same way that they did with the alligators. Write out what your equation should look like, define your variables, and then actually start writing the equation. If you can write out in words each section to the equation, then actually writing the equation will be much easier. So pause the video, take a few minutes to work on this Got It question. These are some answer choices that you can pick from. And the actual correct answer is B. Now, one way that you can do this, again, is using a table of values. And so for satellite radio service, this is an example of what your table could look like. For the first one, I labeled it A. You would have, at 0 months, basically when you initially get the service, you have to pay $20 because that's the setup fee. But then you increase by 10 every single month. This service starts out at $15 for the service fee, but then increases $11 each month. And if you notice that at the 5th month, that's when both of the services will cost you $70. So that's their point of intersection. So just another way you can do it without graphing, you can set up a table. Now there will be some vocabulary that will go along with section 6.1, and we'll talk about the vocabulary when you return to class. Make sure you have these examples and make sure you've practiced these questions here. You can always go to the internet and Google systems by graphing, solving systems by graphing, and find other practice problems that you can do before returning to class. That way you're prepared to begin your work on your task based on the level from your pretest.